So now what we're going to do is covalent bonds, ठीक है, type of covalent bonds. So there is sigma and there is pi bonds. अच्छा, type of covalent bonds, and first one, sigma bonds. Sigma bonds में के the first bond between atoms is always, अच्छा, that is always a sigma bond. ठीक है, whenever there's a bond that's formed, the first one is always a sigma bond. Between atoms as a second, which properties is key? First thing, I just write down the properties that we'll understand. The second thing is that it's an end-to-end overlap of orbitals. The electron density in a sigma bond, it lies on the axis or right between the two nucleuses. I said it lies on the axis connecting the nuclei in the bond. Third thing is rotation is possible around a sigma bond. अच्छा, ये सही ना, इसकी इसी की प्रॉपर्टीज हैं, all of them are properties of sigma bonds, and we're going to now learn what it is actually, ठीक है? So whenever the two atoms they form a bond, the first bond is always a sigma bond. So for example, if I have hydrogen, तो पहले मैं I'll show you the first type. That's sigma bond type A. That's an S-N-S overlap, orbital overlap. So that's the first type. What happens in an S-N-S overlap is that, for example, if you have a hydrogen atom, so hydrogen has a nucleus, one proton in it, and it's got one electron in its outer shell. And then there is another hydrogen atom which is exactly the same. It's got a nucleus, and it's got exactly one electron in its outer shell. And the two hydrogen atoms they eventually overlap. They both attract each other's electrons. ठीक है, दोनों एक दूसरे के electrons को attract करेंगे. They will try to gain those electrons, and the electrons will kind of get stuck in the middle, and the two hydrogen atoms would eventually form a covalent bond with two electrons being shared. And there's going to be attraction. Why is there an attraction? Because the shared pair of electrons are attracted to the two nucleuses. The covalent bond, when now you've got the attraction that you have is that the shared electrons and the two nuclei are attracted to each other because they've got opposite charges. Now this particular bond, that's a sigma bond, but it's an S-N-S overlap. So this is what happens. कि हाइड्रोजन के पास है एक इलेक्ट्रॉन है, so it's a 1s1 orbital. The other hydrogen is also just has one electron, so it's 1s1. That's the electronic configuration. So what does that mean? It means that there's only one electron around the hydrogen atom, and that one electron is existing in a spherical region around the nucleus. So uska jo charge hai na, that's the negative charge of that one electron. It is distributed in that entire, it's distributed in the entire area. So there's one electron that's existing in this particular region. Uska negative charge pura distribute hua hai. And the other one is kind of exactly the same. Okay, so that's one electron and its negative charge distributed in a particular area, in the particular area around the nucleus. Or dono atoms ek dusre ke na, they'll try and pull each other's electrons. So the negative charge, both of them will try to gain that negative charge. The end result is कि nucleus तो वही रहेंगे, but what will happen is that the two electrons will now, the greatest probability of finding the two electrons would be in this middle area over here. Because the two electrons will be stuck over here. That's the greatest probability of finding the electron. But the negative charge will kind of be distributed. And the highest electron density would be in this middle part. Okay, that's where you'll have the maximum electron density. And that will result in the creation of a new bonding orbital that's known as a sigma bond. Okay, so that results in the formation of this bonding orbital, because both electrons have kind of merged together and the negative charge is now stuck in the middle part. Ye nucleus bhi attract kar raha hai, ye wala nucleus bhi attract kar raha hai, so negative charge is kind of stuck in the middle. Is that clear?
Yes, sir.
So that's an SLS overlap. It's one s orbital overlapping with another s orbital forming a sigma bond or a sigma bonding orbital. So ye wala S tha, ye wala bhi S tha, or eventually they merge. That's it. This is what hydrogen would look like. That's an H2 molecule. Acha, फिर second type इसी तरह. Because you've got different types of orbitals, and whenever a bond is formed, the orbitals, they overlap, they merge together. Okay, so second type जो है option B, that's अच्छा option B जो है वो है अच्छा option B is an S and P overlap. So what this is, that when you have एक atom का hydrogen and the other one is a p orbital. So for example, if you have an HCl molecule or an HF molecule, so normal bond is pretty simple. It's you got a fluorine atom, you got a hydrogen atom. The fluorine has 7 electrons in its outer shell. It's not complete. And the hydrogen has 1 electron. So they both attract each other's electrons, and the electrons will be stuck in the middle. Okay, like a normal bond, and that's a covalent bond that's formed. Fluorine uske electron ko pull karega, and it's not going to leave that electron, so it's going to come along. I said the reality is that fluorine has the electronic configuration of fluorine is 9 electron. That's 1s2, 2s2, and 2p5. That means 2px, 2py, and 2pz. So it's 2 electrons, and then there is 1 electron. And hydrogen over here has just a single. It's got just a single electron. अच्छा, अब आपके पास you've got, So if fluorine is going to attract electrons, then it's going to attract electrons and put it in the 2p orbital, because that's the only place where there's room available. Baki sari jagah fill hai. Hydrogen agar electron ko pull karega, it's got the 1s1 that needs to be filled. So basically the overlapping is happening between an S and a P. So hydrogen has got this spherical orbital, and that spherical orbital has exactly one electron. ठीक है, उसका negative charge, it's distributed in that spherical region, and there's exactly a single electron in it. Fluorine jo hoga, that's got a p orbital that needs an electron. So if I were to draw fluorine, that's going to look like this. It's this is fluorine, and it's going to have a p orbital. सही कर लेते हैं. I said it's going to have a p orbital, and it's also going to have a single electron in it. And they will start to, so there's a single electron in this p orbital. It's negative charge distributed in this p orbital. उसमें electron है, दोनों एक दूसरे के electrons को pull करेंगे. They will attract each other's. So what will now happen is that the two orbitals will overlap. The nucleuses will stay wherever they are, but the electrons are getting attracted. And again, the maximum electron density would be somewhere in this middle part. But the orbital shape would kind of look like this. It's going to look, it's going to look something like this after it has merged. Okay. The electron density will be slightly higher. Depending on the shape, it's going to be, the electron density would be higher in the middle part. B ka jo lobe hai na, ye wala, that's going to shrink because the electron is going to get pulled to this middle part over here. Or S jo hai wo uske sath merge kar jayega. ठीक है, is this clear?
जी सर.
और फिर आखिरी जो है ना, that's a P and P overlap. So part C जो है ना, that's part C is that's a P and P. So that's your P and P overlap. अच्छा, P and P overlap में होगा कि orbital overlap. अच्छा, इसमें क्या होगा? इसमें बस वही होगा कि one atom has fluorine, the other one also has one atom has P, needs filling, the other one also has P. So fluorine molecule, that's what it will be. Two fluorines trying to complete the outer shells, trying to gain electrons. Both of them have one electron missing. Achha, the other fluorine, और ये दोनों आपस में overlap करेंगे, they'll merge in the middle part over here. So fluorine के पास, it's this one also has, both of them have exactly the same electronic configuration with 2p5, which is 2px2, 2py2, and 2pz1. तो electron उसको 2pz में चाहिए, ठीक है? That's where it needs electrons. तो यहाँ पे वही होगा कि this is what a p orbital looks like. It's got just one electron in it, and that's your fluorine. I'm ignoring all the other orbitals because they're already full. I said the other fluorine would be exactly the same. It's going to have it's also going to have one electron in this entire area. और दोनों एक दूसरे के इलेक्ट्रॉन को पुल कर रहे होंगे, and the end result is that the two nucleuses, the electrons will be stuck in the middle part, and this is how it's going to look like. कि यहाँ पे maximum electron density होगी middle में, the probability of the electron being on the other side will decrease, and that's what a p and p overlap looks like, and that's your sigma bond. ठीक है, is this part clear?
जी सर.
Yes, sigma bond की 3 types. SNS overlap ये draw करने को आएगा, ठीक है. अच्छा, the other thing is that they might ask you to draw any sigma bond. तो आपने बस यही शो करना है कि electron density is right in the middle. That's about it. और इसमें याद रखना कि every time where there's the first bond is always a sigma bond, the rest of the bonds are pi bonds. तो pi पे आ जाते हैं कि what are pi bonds? तो पहला बॉन्ड जो बनेगा ना, that's going to be an end-to-end overlap of orbitals. It's ये end-to-end overlap है. अच्छा, pi bonds, also known as the symbol pi. तो pi bonds क्या होते हैं? Pi bonds में होता है कि you've got जो second bond बनेगा ना between atoms or any other bond, like if you have a double bond or a triple bond, the first bond was a sigma bond, the rest are all pi bonds. ठीक है, so first bond between atoms, first bond is sigma. The rest, first bond between atoms, and the rest of them are all pi, or rest of the bonds. और इधर मतलब ये है कि if I have a sigma bond, for example, if I have वो HH का molecule है, so that's definitely sigma. But if I have a double bond, for example, if I have oxygen, double bond oxygen, so the first bond is sigma, and the other bond is going to be a pi bond. That's why you've got a double bond. If you've got a triple bond, so that means the first one is sigma, and then you will have 2 pi bonds after that. अगर कोई बड़ा molecule कर लेते हैं, let's say you've got CH3, अच्छा इसके अंदर अच्छा इसके अंदर इस molecule में figure out करना है कि how many sigma and pi bonds you got. So the first bond between any two atoms, that's going to be sigma. So this is sigma. This one is sigma. This one is also sigma. This one is sigma. ये भी sigma है. Double bond है, that's 1 sigma, and then there is 1 pi as well. यहाँ पे it's sigma. This one is sigma. This one is going to be sigma, and it's going to be 2 pi bonds. ठीक है, तो the other thing about this one is ये clear है ना?
जी सर.
अच्छा, the other thing about this is कि the first bond is always sigma. The other thing about this is कि अच्छा इसके बाद क्या चीज, इसके बाद ये कि it's a sideways overlap of orbital, not an end-to-end overlap. अच्छा, then there's it's a sideways overlap. अच्छा, then there is the other stuff which is okay, there's no electron density lies above and below the axis, not in the middle of the two nucleuses, So that lies above. As a connecting the nuclear and not in the middle. Third thing is, okay, it's rotation is restricted. Around a pi bond. Because that's the third thing. Anyways, let's make a pi bond. So, for example, I've got an oxygen, double bond oxygen. So, jab it double bond hoga, triple bond hoga, that's where you'll have a pi bond. So, let's say you got an oxygen, double bond oxygen. Now, oxygen's electronic configuration is 1s2, 2s2, and 2p4. That means 2px is 2. And both 2py and 2pz have 1 electron each. ठीक है, तो ये आपका ना ऑक्सीजन का इलेक्ट्रॉनिक कॉन्फ़िगरेशन है. Just hold on. अच्छा, that's the electronic configuration of oxygen. अब यहाँ पे ये कि so that means oxygen needs electrons in 2 of its orbitals. The other ones are full, but oxygen needs electrons in 2 of its orbitals. One is 2py, the other one is 2pz. तो अगर मैं एक ऑक्सीजन ड्रॉ करता हूँ ना, that's, let's say this is 2py. Remember, axes arbitrary होते हैं, तो let's say 2py, and you've got another one which is 2pz, और इसके अंदर भी ना एक इलेक्ट्रॉन है. So that is what the oxygen would kind of look like. ठीक है? So that's how probably the oxygen looks like. It's got 1 electron over here, and it's got 1 electron in the other axis. Okay, so that's, and there's going to be another oxygen which is going to be exactly the same. कि उसके पास सब कुछ वही है, and it's exactly the same. उसके electrons को उधर से इधर shift कर लेते हैं. ठीक है, उसका blue one. Now, what will happen in this case? So 1 electron is buzzing over here, 1 electron is buzzing over here. यहाँ पे भी exactly same है. First thing is there's going to be a sigma bond that will be formed. Okay, there's going to be an end-to-end overlap of orbitals. जो middle वाले ना, they'll attract each other. So इसको बल्कि यहीं रख लेते हैं, copy कर लेते हैं, just a second. So the first thing that will happen is, okay, there's going to be an end-to-end overlap. ये atom जो है ना, वो उसके electron से attract होता हुआ, they'll middle में ना, they'll start attracting each other's electrons. And when they do that, the middle part will start, the electrons in the middle will start to overlap. And when they start to overlap, the electron density will increase in this middle area over here. So यहाँ पे electron density ना ज़्यादा हो जाएगी. So the probability of finding electrons in this area will be a lot higher. ठीक है, that's going to be a lot higher. और यहाँ पे ना इस side पे, दूसरी side पे, the electron density will shrink. ठीक है, it's going to become, I mean, the chances of the electron going to the other side, that will be very less. ये clear है, sigma bond बन गया. Is that clear?
जी सर.
अच्छा, अब ये कि ये ग्रीन वालों का क्या होगा, because यहाँ पे भी there's an electron missing. ठीक है, there should be 2 electrons. There's only 1 electron that's buzzing in this area, 1 electron buzzing in this area. So they'll start attracting each other's electrons, and when they do that, they will start attracting. Both of them will try to attract each other's electrons. Now these orbitals are sideways. That means beach mein to aa nahi sakte. That's already occupied. Plus unki alignment bhi isi tarah thi ke they were on axes that were parallel to each other. So they'll start overlapping with each other, which means that the electron density will become maximum at the top and also in this bottom part. तो यहाँ पे electron density maximum होगी और उधर top पे भी electron density will become maximum. The electrons will kind of get stuck above and below the axis. So लेकिन maximum यहाँ पे होगी, ठीक है, इस middle area में. So that's what your pi bond would look like. There's going to be a sideways overlap of orbital, and that's your pi bond. Or beach में, middle में, there was the sigma bond that was formed. तो ये आपका sigma हो गया. और ऊपर जो है ना, that's your pi. इसको थोड़ा, और ये ऊपर जो बना है, that's your pi bond. और हर दफा ये होगा, whenever you see a double bond, बस आंखें बंद करके ना, just draw this thing, the green thing. ठीक है, that's going to be your, and you just have to draw the outline, not the whole thing. Okay, if you're being asked to draw this, so just draw this part. और जरूरी नहीं वैसी शेप, बस ऊपर और नीचे इलेक्ट्रॉन डेंसिटी ज्यादा होनी चाहिए, ठीक है. Also this one as well. So you just draw this part. Or मतलब different shape, there's many ways of drawing the pi bond. Some people just what they do is they, कि उसकी जो simplistic version है इन दोनों की, the very simplistic version is that what you do is you take 2 nucleuses, and that's the most simplistic version. You want to show a sigma bond, all you do is you just show a spherical orbital in the middle. That would be recognized as a sigma bond. You want to show pi bonds, all you have to do is draw. There's going to be electron density above, and there's going to be electron density below. That's your pi bond. So एक overly simplistic version of the same thing. ठीक है, ये बेहतर है, ये draw कर लो instead of drawing this one, but that would be sufficient as well. I can show you pi bonds. 1 second. अच्छा, तो यहाँ पे जैसे ये से ड्रॉ किया हुआ है, just overlapping, you can just draw 2 rings, one on top, one on the. फिर ये एक और है, उसमें थोड़ी सी उसने shape change की हुई है, but kind of the same thing. ठीक है, ये वाला है, that's उससे फिर थोड़ी सी shape change की हुई है. अच्छा, ये इससे यहाँ इस तरह शो किया हुआ है, ठीक है, so there are many ways to actually show this one. इसने मेरे वाले तरीके से शो किया हुआ है कि वो इलेक्ट्रॉन डेंसिटी जो है ना वो उस तरह ड्रॉ की है जैसा मैंने शो किया हुआ था, ठीक है। तो that's up to you, ठीक है। both of them, all of them will be acceptable, and that's what a pi bond is. The important thing is the properties that electron density lies above and below the axis. So whenever you have a sigma bond, after that a pi bond will be formed. Electron density will be below and above the axis connecting the two nucleus. Triple bond किस तरह होगा वैसे? If you had a triple bond, so where would the other pi bond form?
सर इसके पीछे।
हाँ, ट्रिपल बॉन्ड में होगा कि यहाँ पे अगर अच्छा ट्रिपल बॉन्ड पाई बॉन्ड ये तो नहीं है। अगर वो 3 डायमेंशनल शेप मिल जाए सो हाँ ये सही है, बल्कि इतनी भी सही नहीं है, कोई ज्यादा बेहतर पिक्चर नहीं है। हाँ ये सही है, ये अच्छी है। अच्छा, this is how a triple bond pi bond would look like. Okay, one overlapping will happen on one axis, the other overlapping जैसे blue one है, ठीक है। if you can visualize the blue one के ऊपर से जा रही है और नीचे से जा रही है, ठीक है। then there's a purple one पीछे से जा रही है और आगे से आ रही है, ठीक है। so over here if I want to picture another pi bond, तो imagine करो कि इस तरह ये green वाला ना, there's another one which is now in a different plane which is towards you, यानी इधर से बाहर आ रहा है, सामने से आ रहा है और पीछे से जा रहा है। तो इसी के ऊपर if I draw, अच्छा if I were to draw जैसे N2 का molecule है, N2 का molecule will have a triple bond because even the 2pz will need one electron. तो अगर मैं N2 के molecule को show करता हूँ, N2 का molecule कोई भी आपको नहीं कहेगा क्योंकि it's 3 dimensional, but the N2 molecule would kind of look like this, that there's going to be a third orbital in nitrogen which would need electrons, and that third one is going to be on the z-axis. So let's say आपका ना z-axis है, और अच्छा third one that's so that's your z-axis. तो ये red वाला orbital there's red में draw करें, pink कर लेते हैं। अच्छा, so there's one orbital on the z-axis coming towards you and going into the page, वो पीछे की तरफ जा रहा है। तो यहाँ पे वही होगा कि the green ones will overlap and then it will be that there'll be one orbital that will be अच्छा that's going to be on the z-axis. तो जो z-axis वाला है ना, that's going to form another, उसको कर लेते हैं कोई, so there'll be overlapping happening on this axis. So it's going to be कि यहाँ का एक ऑर्बिटल और यहाँ का एक ऑर्बिटल, अच्छा फ्रंट से ओवरलैप करेंगे और फ्रंट से, और तो ये सामने से ओवरलैप हो गया। अच्छा, ये एक सामने से ओवरलैप हो गया और एक इसके ना बैक साइड से, बस एग्जैक्ट पीछे से भी ओवरलैपिंग हो रही होगी। तो यहाँ पे एक ऑर्बिटल होगा दैट विल बी ओवरलैपिंग, वो 3 डायमेंशन में ना उसकी बैक साइड से भी ओवरलैप हो रहा होगा, ठीक है। तो उसके सामने से और उसकी बैक साइड से ओवरलैप कर रहा होगा। So that would what 3 pi bonds would actually, सॉरी 2 pi bonds. 2 pi bonds से ज्यादा नहीं बन सकते क्योंकि now अच्छा now you've run out of space, so you can't really form you can't really form more than this. इसको भी सही कर लेते हैं कि अच्छा वो फ्रंट से और बैक साइड से। तो ये क्लियर है ये वाला?
जी सर।
और रोटेशन रिस्ट्रिक्टेड होती है ना पाई बॉन्ड, लाइक whenever you have a double bond, remember shapes of molecules, so double bond molecular model, तो ये याद रखना कि वो कल कर लेते हैं, लेकिन अभी कोई मॉडल मुझे नजर नहीं आ रहा, तो रोटेशन वाली बात पे हम कल डिस्कस कर लेते हैं, ठीक है? देन वील डू पास्ट पेपर क्वेश्चंस, और से वो sp हाइब्रिडाइजेशन विल डू दैट एज वेल, ठीक है? जस्ट रिमेंबर शेप्स ऑफ मॉलिक्यूल्स, व्हेनेवर देयर इज अ डबल बॉन्ड जस्ट ड्रॉ दिस थिंग, दैट्स इट। ट्रिपल बॉन्ड का क्वेश्चन आएगा नहीं, दे जस्ट आस्क यू टू ड्रॉ अ बाई बॉन्ड, जस्ट ड्रॉ दिस, दैट्स इट। दे आस्क यू टू ड्रॉ अ सिग्मा बॉन्ड, ड्रॉ दिस थिंग। सबसे आसान बल्कि ये है, इसकी ओवरऑल समरी है। If somebody asks you to draw pi bond, ये दो rings ऊपर नीचे draw कर दो. If somebody asks you to draw sigma bonds, draw this thing in the middle, ठीक है? चलिए ठीक है, कल बात होती है, ठीक है?
ओके सर, हाफिज।
ओके, हाफिज।